Alright guys, this video is going to be about the first diagram that you have to do, which is one of your essays. And essentially what you're going to get is you're going to get a blank diagram, and you're going to have to fill out the names and the enzymes in these 10 steps of glycolysis. Now I know that this can feel very overwhelming at first, and so the purpose of this video is, number one, to help you see what goes where. You can also go back to your notes, and I showed you that the black words were the product names, and then the red words were the enzyme names. You also have access to this video, and so you can easily go in and look at those. I will tell you that, remember that these essays are not necessarily something that I am responsible for, but we do have to do them for the professor who teaches these biology classes here at TC. Now, I know it does feel overwhelming at first, but I am going to go over just some helpful ways to help you remember. I will also tell you that I give you a word bank. Okay, so if you're in your study guide, which you need to get out if you don't already have it out, if you're in your study guide, there is a word bank, and that is the same word bank that you will receive the day on the test when you have to fill out these diagrams. What I have found in the past is that students who prepare actually do very well on this. Students who do not prepare do not do well. So it's just a matter of taking the time to study it and literally memorize. And I'm not a fan of memorization, but in this case, it's about memorization. But I will say that the tips that I'm going to give you today could be helpful. All right, so we're going to start. I'm going to actually go to my little tips page, okay? And so this is something that I would encourage you to kind of use as you're trying to figure out what goes where. First of all, we can almost split the terms in half because you're labeling 10 reactions with the products and the enzymes that catalyze them. So about half of your terms are enzymes. Now, all enzymes in this particular scenario end in ACE, okay? That's a common ending for an enzyme. Now, not all enzymes that exist end in ACE, but most enzymes, their name ends in ASE. So automatically, we can split our words into about half. And if it's an enzyme, it's going to be written on an arrow, okay? So when you're filling out this diagram, all of your ACEs should be placed on an arrow. Now, even more specific than that is there's a specific type of enzyme called a kinase. And we're going to see 4 different kinases. Now, what kinases do is they phosphorylate. And remember that phosphorylation is adding a phosphate to something else. And so in your pictures, you're going to see ATP like 4 different times, okay? So in your pictures, if you see ATP, the enzyme that catalyzes that particular reaction is going to end in kinase, okay? So that should be another helpful tip, and I'll kind of point that out again as we go through. Now, something else that could be helpful to you, and I know you're not in organic chemistry, but when you're looking at organic compounds, they're carbon compounds, the carbons are always numbered, okay? So just to kind of give you an example here, this is glucose, and in glucose, this is a picture so I can't easily highlight on it. In glucose here, you can see that, let's see if it'll let me, it's not going to let me draw on it. This is the first carbon here. I know it's not there, but where these bonds are on your pentagons and your hexagons, most of them represent a carbon. So this is carbon number 1, 2, 3, 4, 5, and then your 6th carbon is right up here. Sometimes you'll see them drawn as chains. The carbon number 1 is always going to be at the top, and then they go down 2, 3, 4, 5, and 6. Okay. So I just want you to be aware that the numbers of the carbons are going to be important because they're actually going to help you in naming some of these products, okay? And I'm going to point that out as we go through the diagram. All right, so let's go back. All right, so initially what you have here up at the very top is you have your energy investment phase, okay? That's going to be something that you're going to have to fill in. And notice in this case, ATPs are going in over here, okay? So ATPs are going in the energy investment phase. In the energy payoff phase, they are coming out. So if you pay attention to those arrows there, okay, we can see that. Now, something else that you should know, and that you should know for the test as well as just in general, because this is important information. But we're starting with glucose, all right? So the initial compound in glycolysis is glucose. And we should know from what we've already covered that our ending result, I don't know how to get off of this, is pyruvate. So if you get any of your compound names, we should know that we're starting with glucose and we're ending with pyruvate, okay? So right there are 4 that we should be able to get right, okay? So energy's going in where the ATPs are going in, energy's coming out where the ATPs are coming out. We're starting with glucose and we are ending with pyruvates, okay? So notice here the arrows, all of the arrows have an ACE on them, all right? And so anytime you see an arrow, you should have a word that ends in ACE written on it, okay, every single time. And then the product names are going to be underneath the pictures, okay? So in this case, we have glucose, and then down here at the very end, we had pyruvate. So the product names are always going to be under the pictures, okay? So that right there should help you out in kind of at least knowing what goes where, enzymes versus products. All right, so going back up to the top. Now let me kind of show you some other hints and clues, all right? So here we have our starting glucose, okay? Now if we look at our picture, this is carbon 1, 2, 3, 4, 5, and then there's a 6th carbon up here, okay? And so what we see, the only difference between this picture and this picture is that a phosphate was added, okay? You see that little yellow P right there? Now in your picture, it's not going to be colored, but if you look in your picture, a phosphate has been added to this molecule, okay? So we went from glucose to glucose 6-phosphate. What that means is it was added to the 6th carbon, okay? That 6 tells us it was on the 6th carbon. So that should be a pretty easy change right there. All right, so glucose to glucose 6-phosphate. Now hopefully you know from geometry that 6, the prefix is often hexa or hexo, and we see ATP in the picture. And I told you that anytime you see ATP in the picture, it's going to be a kinase, okay? So hexakinase. So I know these are big, funny words, but if you kind of study it, okay, there is method to the madness. It's not just completely random words and random enzymes. If you really look at what's going on, you should be able to connect that, in most cases, to the enzyme and to the products, okay? So there's your first product and enzyme. All right, moving down a little bit. I'm not sure why sometimes this works and sometimes it doesn't. Okay, so here we have glucose 6-phosphate, and essentially it's rearranged, okay? It's the same chemical composition, but it's going to be turned into its isomer. It has the same chemical structure, the same chemical formula. It's just been rearranged. And so another monosaccharide is fructose. And so all we've done here is that glucose 6-phosphate was turned into fructose 6-phosphate. Once again, phosphate is on that carbon, okay, that's your 6th carbon. And so if you look at the enzyme name, it's kind of long and funky, but phosphoglucoisomerase. So the phosphate was on the glucose, we turned it into its isomer fructose, and there you go, okay? All right, next picture. We're adding a phosphate, okay? So here's one phosphate, we are adding another one, all right? So fructose, it's still fructose, 1 and 6, so it's on the 1st carbon and the 6th carbon, bisphosphate. Bi means 2. Okay, so I know they're big words, but we go from fructose 6-phosphate to fructose 1,6 bisphosphate. Once again, 2 phosphates there. They're on carbon number 1 and carbon number 6, so that's exactly where that name is coming from. And we have phosphofructokinase. There's a kinase. What's in the picture? ATP. Okay, kinase is phosphorylate. All right, so there's definitely some hints there. Now, I don't really have anything for you with aldolase or aldolase. I will tell you on your test you only have to write it once. You don't have to write it on both arrows. But aldolase is going to turn fructose 1,6 bisphosphate into dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. Okay, these G3Ps. And so essentially what they do is they turn it into this, and then isomerase here. This is the only enzyme that's not on the outside because the arrow's in the middle here. So isomerase is going to be written right there. But isomerase is, once again, you have isomers, okay? These are the same chemical formula, they're just rearranged. All right, now what we're ending with down here in step 5 is what we're starting with up here. Okay, so there's your glyceraldehyde 3-phosphates. Notice over here, there's 2 of everything because in this first half, we split it into 2 molecules. In the second half, there's going to be 2 of everything, okay? So we're starting with glyceraldehyde 3-phosphate here. All right, we look at our picture. We have a phosphate there. Here it was on the 3rd carbon. Now we have one on the 1st carbon and the 3rd carbon. Okay, so there you see 1,3-bisphosphoglycerate. Okay, remember you'll have a word bank. You don't have to spell these, you just have to recognize them. But I have a phosphate on carbon number 1 and a phosphate on carbon number 3. And so there's your name right there. Once again, there's 2 of those. Okay, so your names are written by that number 2. All right, we look over here at our enzyme, triose phosphate dehydrogenase. Now, we have a clue here too, in that dehydrogenase means we're removing hydrogens. And notice this is where we have that reduction. Okay, we're moving the hydrogens. And so I just want to show you that dehydrogenase, this is the picture where you see the NADHs. Okay. All right, moving on down, we had 1,3-bisphosphoglycerate. Notice the next one is 3. Okay, so that phosphate on the 1st carbon is gone. We now just have a phosphate on the 3rd, so 3-phosphoglycerate. Okay. Over here in the picture, we have an ATP, phosphoglycerokinase. So you can see that the first part of the kinase kind of goes along with the products, phosphoglycerate and phosphoglycero. Okay. Okay, scrolling on down, we see pretty much a very similar molecule, but now the phosphate is on the 2nd carbon, so 1, 2, 3. So we've gone from 3 on the 3rd carbon to 2 on the 2nd carbon. All right, so moving on down, okay, over here's your enzyme, phosphoglyceromutase. Okay, that's just one you're going to have to remember. There's not really any clues in the picture, except for it has that phosphoglycero, okay. Moving on down, all right, we have 2-phosphoglycerate, all right. We still have that phosphate there, but we've kind of rearranged it. And so now we have phosphoenol pyruvate. Now, to me, the helpful tip here is we should know that we end in pyruvate. So your phosphoenol pyruvate is the one right above it, okay? And so once again, we have 2 of those. All right, over here, we have enolase is the name of our enzyme. I don't really have anything special for you there, except for you do have the enol pyruvate. That's an organic compound thing. And then finally, we have our last and final enzyme. We have ATP in the picture. We're ending with pyruvates, and there we have our pyruvate kinase, okay? So this is what you're gonna need to fill out and study for your test, okay? We still have a little while before you have to do it. So once again, you're gonna have to label these here. You have a word bank in your study guide. I've tried to kind of help you out with as many clues as I can. I know it feels overwhelming at first, but if you study it and you know the basics, like glucose to pyruvate, ATPs equal kinases, you use the clues that I've given you, then hopefully you should be able to fill that out, okay? If you have trouble seeing this particular one, you can always Google a picture online if you need to look at one that's bigger. You can also look in your PowerPoint. These same reactions, enzyme, product names are all in there as well, okay? All right, guys, that's all I have for you today, and I will see you tomorrow on the videos in the next part of cellular respiration.